Your last speaker is Dr. Cornelius Toole Jr. from Tougaloo College. He finished a postdoc here with Dr. Ullmer, who's now sitting over here, in the Center for Computation and Technology. And
So good morning. It's a pleasure and honor to be here. Exactly 365 days ago, I either was getting ready to walk across the stage or had just walked across the stage and was put it as a PhD. Actually, I was a doctoral student here. And so this is basically the structure of my talk. So I'm going to talk about how I got here briefly, and then I'll talk about my life as a graduate student before I got here and while here. Then I'll talk about some of my research and academic experiences, and then we'll talk about season one of being a PhD, and specifically being an assistant professor. All right. So I'm from Mountain Bayou, Mississippi, which is a little small town in the Mississippi Delta. You can take Highway 61 straight there. Growing up, I grew up right on Highway 61. I did undergraduate and master's studies at Jackson State University in computer science. That was my research interest. That's what I did my master's research on. I'm going to take another take on this information, but my research is all about, or at least my dissertation research was about ways of integrating physical user interface elements. So RFID tagged objects that can be tracked visually, physical controls, buttons, knobs, things with accelerometers so you can track motion. And often doing this in distributed computing context. So the software is not just running on your laptop or on your tablet, but the software is distributed across different devices. And it may be in the same room, across campus, maybe in the same state, and maybe on different continents. And so I by the time I finished undergrad studies, I kind of had vague notions of using computation to kind of be able to design and build anything. I also had an interest in image making. For a little while, I was a art and computer science double major. And that led me to visualization. I was initially interested in computer graphics, but that was pretty math heavy, and I kind of had my feel of the math, and so I thought, and I was like, well, visualization is more application. It's to solve problems. I also took interest in distributed computing. While in the master's program at Jackson State, I took a class by Dr. Jeffrey Fox, which is one of the preeminent researchers in distributed computing. Did a lot of work in web services, mashups, or whatever. And so I tried to kind of mash the two up, right? Take distributed computing and visualization. And so the SciViz group at Lawrence Berkeley Lab, they actually had a distributed visualization research initiative. So I interned out there, had a great summer. I was doing visualization research, like ways to look at the inner workings of simulations that look at things like core collapse supernova, or maybe the detonation of a nuclear device could be another application. But from that experience, my LBO mentor served on my thesis committee. And basically, I was doing research management techniques for distributed viz. So basically, viz, you can kind of think about it as it's a process, like a data flow process, where you go from data to images. And so you can kind of segment that workflow and distribute different parts of that to different machines. And so you might do that for reasons of trying to get better performance, being able to visualize large amounts of data, or maybe just make those resources available to more people. This relationship basically led me, they were having a visualization summit at the LSU CCT. And that was actually what put LSU on my radar for doctoral studies. So part two, lifestyles, fixed budget, and nerds. So I started doctoral studies here at the PhD program 2 weeks before Hurricane Katrina. That disrupted the professional market. My wife, which if I have time, I should actually kind of tell that story, tell stories about getting married as a grad student and stuff. But it kind of disrupted the professional job market. And so basically we were like, well, you already have a master's, you know, you kind of got this grad school thing now. It's only going to take 3 years, right? So why move? So my wife never relocated. She stayed in Mississippi or whatever. So I basically logged over 100,000 miles, maybe closer to, maybe between 150 and 200,000 miles between Jackson and Baton Rouge. I'll share that photo set if I have time at the end of the talk or whatever. And so basically over the course of 7 years and several all-nighters, either hacking code or studying for exams or finishing assignments, bunch of debates, philosophical debates, technical debates with my lab mates, 2 babies, a mortgage, a couple of cars, lots of travel, some of it international. You know, here I am today with a PhD. So these are some images of Professor Ullmer here and some of my lab mates who are in different projects. This is a map of some of the geolocated photos I've taken. So you see at least one pin over there out somewhere in the middle of the Atlantic Ocean. Actually, like about a year and a half ago, I flew to Boston and drove through upstate New York and Massachusetts or whatever to Canada or whatever. So, kind of to sum that up or whatever, the nine or so years of graduate life has not been one of total deferred gratification. I don't know, maybe that's why it took so long. But I had a great time. I wouldn't trade it for the world. I don't, in terms of, you know, those type of decisions or whatever, I probably wouldn't take those back. So, yeah. All right, so now I'll talk about my academic and research experience. All right, so first I'm going to kind of give some background information. So again, earlier I said that my dissertation research was about integrating physical, interactive, or user interface elements in distributed computing context. And so here you see this term here, tangible user interfaces. And so these are user interfaces that use physical objects both for control and representation. So for instance, this is effectively, this clicker here, it's effectively a keyboard, right? It's got 2 buttons for moving back and forth. Mouse, pointing device. Yes, it's a physical object and you can use it to control your software, but the mouse doesn't necessarily represent any kind of information or process in your application. So these are just different examples. So, you know, like this, we're using wireframes here to represent buildings, and so we can kind of simulate an urban resource, support our urban resource planning and management application. This is like a digital music creation application, and so on. In terms of the domain applications that we tried to support, one of the most frequent ones that we targeted was visualization, so visual data analysis. And so visualization as a computational process, basically transformation of data into irreducible forms. Typically we focus on things that we can see, but I guess in the way that the research field is kind of divided up, it may also include things like things we can hear as sonification, or things we can feel. I did my doctoral work in the tangible visualization lab, and so some of the ideas that we explore were also physical representations of data, right? So not just a plot, but like some kind of physical object you can kind of hold and feel and manipulate or whatever. And so typically this process is modeled as a data flow pipeline. And so here we see, I forgot to start my timer, so you can kind of help me with the timekeeping. Here we see several images of different applications involving tangibles, and some of these are imagined and some of these are realized. And so, yeah, I don't know how well you kind of be able to see, but that's me right there, that's me there, whatever. Up until about 2 years ago, I had a lot of hair. So if you find pictures of me while I was here at LSU, I may not look like that anymore. Basically, you know, we see these different instances of these tangibles, and actually some of them, you kind of see some of the same design elements kind of repeated over and over again. And so that's kind of, basically we have this thing here, we have like these wheels and these dials, and we use these to kind of do parameter explorations, right? You can imagine these dials would be associated with a parameter like time or some feature or property in your application or whatever. Could be spatial parameters, could be different for different metrics or whatever that you're taking. So kind of the same element, right? But in a lot of cases, the hardware and the software behind these things are all different. Different operating systems, different software built with different programming languages, different types of electronics. And so my research is about trying to tease out what's common across it, right? Of course, the affordances are all kind of the same, right? The ability to turn a knob or press a button or to flip an object or whatever and have those changes and then, those changes of that object in time and space mean something in the software. In a lot of cases, the software that this stuff was all connected to, it had to be rewritten every time we wanted to do a new version of these interaction devices. And so I was just basically trying to tackle the problem of trying to, as much as possible, save as much of that work, to have as much code reuse as possible, to make it easier to integrate these into different environments, so different use contexts. And so the first, I guess, experience I'll talk about one in which we wanted to take this technology and demonstrate how this could be used for K-12 education. We kind of had some experiences where we had supercomputers and clusters and graphics workstations, and we had these funny interaction devices and high-speed networks that we were doing for scientific computational science. Could we use it for education? And so in this demo, we had two sites, one in Baton Rouge and one in Raleigh, North Carolina. We had elementary school-age students in both sites, and they were trading tutorials. They were teaching each other about different topics. So here are the students here from Louisiana. They were giving a presentation about hurricanes. And so what we see here, over here, this is a multi-data visualization of different types of either simulated data or collected data pertaining to Hurricane Katrina. LIDAR, AdCert, which is a wind and water surge model, I believe. And so they were using this, right, as like a visual aid for sharing their experiences, right? They were, toddlers or whatever when Katrina happened. And on the other side, the kids there were sharing their lessons. They were giving a tutorial about the cardiovascular and respiratory system. And so they had a model of the heart and lungs. All the visuals were being generated in Baton Rouge. We had an instance of these parameter exploration tangibles here, and we had a copy of those in Raleigh, and I was on the other side in Raleigh. So basically, they could both see the visualization at about the same time. Of course, there is some delay. I mean, no matter how fast the network, you still have speed of light. But close to real-time interactivity. They could share they could share control of the visualization. These devices kind of had the ability to give active feedback, so you could kind of know what the other user of the other site was doing. Like we could lock or clutch the wheels. And so the next experience I'll talk about is, so I've been being both in the tangible visualization lab and also in the visualization group at the CCT. We kind of had this effort we called the EA build, and I don't even remember what this acronym even means, but basically we were trying to combine parallel data streaming, parallel rendering, and tangibles to create this large-scale interactive data visualization environment. And so I wrote the software to integrate tangibles. We demoed this at different places, but this kind of culminated in a demonstration at Scale 2009, or the International Scalable Computing Challenge, where we won first place in a competition, to demonstrate innovative uses of high-end, computation. And so what we see here, and actually I have a video. I'll come back to it. What we see here is, so I have some physical knobs here, and what we see here, this is this is simulation output of spiraling black holes. And I think this data set is probably like 64 gigabytes. pretty big, data set. We basically had to visualize it on I think we used like 8 nodes on a cluster or whatever with some really expensive video cards somewhere in the machine room here on campus. But we had a colleague, it was actually supposed to be me in Shanghai at the time. I couldn't go to Shanghai because the turnaround time for getting a visa had been extended by China because of the H1N1 influenza epidemic that was going on at the time. But it just so happens I had a lab mate from Shanghai who was going home for vacation. So, that saved the day. And basically we were doing the visualization here in Baton Rouge. We had data streaming in from Europe, probably some places in the Midwest, and different places in Louisiana. One of the reasons I actually came here is because of LONI, or the Louisiana Optical Network Infrastructure and Institute. Not many places have a 40 gigabit optical network, so that's a pretty attractive resource. So we had data coming in from all those places, and our colleague was in Shanghai driving all this. She was basically driving it much like she would have, if it was on her laptop on her workstation in the same room. So, this is just a brief video. So, we kind of did some cuts or whatever. But this is the simulation output, and I'm going to skip it. At some point, you will see me pulling the knobs or whatever stuff to manipulate this visualization, both spatially, so translation in space and moving back and forth. Moving through time steps within the simulation. All right. Okay, so let me move on. All right, so the next project I'll talk about I've been around for some projects that I haven't told you about, and the ones you've just seen. When we were building these tangibles, we were integrating other interaction devices developed by other groups or other companies. For these different applications, and we were trying to, we were starting to gain an understanding of how we could do this better, how we could have a shorter iteration time. Also, my advisor, he was teaching a new class in human interface development and technology, and so I served as a TA for that class. And so the students were going to learn like the basics of graphical user interface programming. So you think basically all the software we use today, right? Windows or OS 10 or Linux, but also even the tablets, smartphones, and iPads, and so on. And so they just learned GUI programming. And so now, we were trying to introduce these funny physical interaction devices. So they needed APIs that would kind of give them the same, look and feel, kind of give them the same hooks they would use to create graphical user interface. And so I wrote those APIs, and basically it became something I call a toolkit, so Technical User Interface Toolkit. And so it was basically designed to integrate tangibles much in the same way as one you would integrate graphical widgets. So I don't know if you've ever had any experience doing app design and development for iOS or for Android or whatever. You basically would have run across this concept, something called Model View Controller. And that's all about just basically taking software and dividing it into different components. And so the parts that you can see or touch or click or manipulate, that's the view. And the model is basically things that are represented by the view, and the controls and connections between the two. And so basically giving them the same type of hooks for tangibles. And so we use this in 2 cycles of CAC 4700. And so these are just different examples of that. So actually this first image here, so this was this is one of the better projects in that particular year or whatever, where we had a student who was really interested in the Gulf oil spill at the time, and she kind of wanted to do a project that would kind of show some of the impact. And so this is actually running on the Microsoft Surface table. So at the time that was like $15,000 tabletop computer that you could manipulate much in the same way you could a smartphone. And so basically I wrote software to integrate the touch interaction from the table with interaction with with the iPad or whatever. All right, so this is a short video demonstrating that. So what we see here, right, is we see kind of the same type of arrangement. We have these, what we call, it had different names. We call it the parameter interaction tray. We call it now the casier, right? So basically like an encasement of physical interaction UI elements. And so some of these wheels are mapped to spatial parameters. So just like they can kind of pan and zoom this 3D globe application with touch, they can also manipulate those parameters with the dials. And so this is mediated by the table. What we just saw that user take away, that was the same interface on an iPad. And so I wrote software that kind of basically tied it all in together. So where am I for time? Okay. So let me move on to I kind of want to make sure I get this in. All right. So if I have time, I'll kind of go back, right? So it's like a short, wrote the software or whatever, right? And it's like a small matter of writing a dissertation. So I got the PhD, right? Walked across the stage, hallelujah, I'm free. So basically, it's been a year. As a matter of fact, as I was driving down here on the way to LSU, I got a call from the dean at my current institution with the job offer or whatever. I accepted it, like verbally over the phone. When I got back, I signed contracts and stuff. But it's been a year, basically, since I, got a job. And if we have time, maybe on the panel, I can kind of talk about that experience and how I really didn't go about it the right way. But I came out okay anyway. Okay, so just completed my first year as assistant professor of computer science at Tougaloo College, the small historically black liberal arts college near Jackson, Mississippi. Basically, 40% of the African American doctors and lawyers in the state of Mississippi are Tougaloo alumni. It's a undergraduate teaching college or whatever. And so, so I'm teaching courses in computer science. I'm teaching things like principles of programming languages, senior seminar where you prepare your senior thesis, computer literacy, which is like a general ed requirement. Also taught a course in computer graphics and interactive computing and Java. As far as research, so I'm continuing my dissertation research in distributed interactive systems. I've also been helping to co-develop course material in bioinformatics, which will be that's going to be one of my application domain focuses is bioinformatics. And also this summer I just wrapped up teaching an introduction to computer science at the 41st Tougaloo College Summer Science Program. So you remember I talked about that track record for Tougaloo where a lot of students kind of go on to professional degrees or advanced studies. As a matter of fact, my computer science department is very small, but they're a significantly high number of PhDs or doctoral students coming out of that department. And so we had this summer science program that's been going on for 41 years. So I kind of got thrown in the deep end. I was teaching a computer science class that I wanted to be hands-on for 36 students all at once. And so this first image here is actually from this demonstration I prepared in the spring, where I'm taking like everyday electronics like Kinects and webcams and stuff, and trying to create some of the more high-end, interactive environments like, that I like the ones that we kind of have here at LSU. This is a picture of my daughter here. She's helped me unbox some Raspberry Pi. How many people have heard of Raspberry Pi? So, it's all pretty cool. As a matter of fact, even Intel is getting in the game. I just found out they released their own embedded, x86 based platform or whatever, but it's $200 as opposed to $35 for a Raspberry Pi or a Beaverboard Black. Which is basically the guts of a smartphone or a tablet, right? But they expose all of the guts, and you can connect USB devices and HD televisions or really old TV with RCA inputs. You can connect electronics directly to it and hack or whatever. And so this is just my lab that I set up, and this is actually from about a little less than a month ago. So my students kind of came down with me And so this is me visiting my lab or whatever, some of the students in the lab. So, that's basically been my, my life. It's just basically been mostly teaching, a little research, working with really bright students just like yourself, and just kind of making that transition from a student to professional scholar. So, all right. So, if you can catch me after the talk and you want to get, more details about the technical aspects of my research, that would be fine. But I'm going to just basically stop here. Oh, so let me thank the right people. So, I'm currently funded by the Howard Hughes Medical Institute. I've also received some support from NSF HBCU Up, and these are the various funders for my research while here at LSU. Thanks to Professor Ullmer, various people at the CCT, the Computer Science Department. Thanks to my wife and children for putting up with me and loaning me out to the state of Louisiana and LSU. That's pretty much it. So thank you.